Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Firdaus bin Wan Mazlan, student of Mechanical Engineering, semester 7. So, for the final year project 1, my title of study is Simulation Study of Airflow Inside a Small MOSQUE During COVID-19 Pandemics. This title I will decide with my supervisor, Dr. Muhammad Rozi Maknawi. So I am very thank you to Dr. Muhammad for helping me and guiding me to complete this study. Also to the panel, thank you for your time for listening to my presentation. So for the presentation content, we will conduct an introduction as for the basic what the study, literature review of the founder research finding that have been found using journal and internet sources, and problem statement of what thing that makes me want to do this study, and objective, scope and limitation of the study, and how I conduct this study methodology, how the step by step I have done, and expected result, and lastly is preliminary result that have been got so far. For the introduction of my study, basically airflow is air movement in the building and surrounding area. For the airflow have to create in the building, the presence of air is needed. But also, airflow also defined as the amount of air that passes through a given system or building per unit of time. Basically, air behave fluidly means they will move from the higher pressure area to the lower pressure area. That means the air will move from the higher to the lower pressure area for them. However, in the building, to create the difference between the pressure, the ventilation system is needed. As a pressure difference present in the building, such as, for example, is a ceiling fan, exhaust fan, and air conditioning ventilation. So, after I discussed with my supervisor, so we decided to use air conditioning ventilation because all the research, after I done all the research from the nearby MOSQUE, they all use air conditioning ventilation. Also, to done this study, there are 3 ways in study of fluid, which mean theory analysis, experiment, and simulation, which is CFD. And I have decided to use a simulation study by using a software AnisFluent to create the simulation airflow inside building. And next, I will continue with the parameter that related to the airflow study. First of all is indoor air quality. Air quality within a building and structure, especially it is related to the health and comfort of the building occupants, which means the quality of the air produced in the building that give comfort to the humans that enter in the building. Next is indoor air humidity, which is the amount of moisture in the air. This is related also with indoor air quality, but it's something different between them. So both I will have conduct study also. Next is carbon dioxide concentration in the building, which means amount of carbon dioxide released from human inside the building when they go prayer. For my study is in the MOSQUE, so the time is which mean when they go pray. And for the heat transfer is amount of heat they release to the inside the building when they go there. Heat always move from the warm area to the colder area, and way of heat transfer have 3, which is conduction, convection, and radiation. Next, we will proceed with the literature review, which means research that I have been finding from the journal, from the internet sources that I have finding that I can make as a guidance for me to complete this study. For example, the journal that I have been finding, which is, for example, the first one is a review on weak nature for passive cooling and natural ventilation in the building, and by Fatemah Jomeh Zadeha. Next is for a review of integrated radiant heating and cooling with ventilation system by Chan Zega. Both have create a simulation study, which means show a critical and normal section for the inside the building. For example, in the Fatemah Jameh Zadeha, and for the right section, it show a critical of airflow and thermal comfort. Show airflow, air quality, and thermal comfort inside the building. And for the blue area, it show a safe area, which means the airflow that area is good. Next is from the journal Simulation-Based Feasibility Study of Improved Air Conditioning System for Hospital Operating Room by Zigian. The result showed the velocity simulation analysis inside the operating room. It showed the air movement also from the previous journal I have been telling you before. The next finding that have been got from the journal Effect of Ventilation Strategy of Infection Controls Inside Operating Theatre by Rafat Al-Wakid also show the air velocity vector within the operating theatre. There are 3 cases. It shows also the velocity analysis within the critical and normal part in the surrounding theatre, operating theatre. Next is for the experimental investigation of thermal comfort and carbon dioxide concentration in a MOSQUE, a case study in a warm temperature climate of Yalova, Turkey by Ahmed Yüksela. The result that they have finding from this journal is the indoor air temperature and relative humidity presented mixed value of the data obtained by the 9 data logger. They show a graph of a carbon dioxide concentration times over times. So from all the research result that have been got, I will use this as a guidance for me to create my result at the end of this study. For the problem statement for my study, which is the idea for me to create this study is due to the COVID-19 pandemic. There is an increased number of people that are affected to the virus, especially when they go to the public area, which means public area or building. So the need of airflow, which means to prevent and minimize the chance of virus from spreading inside the building, have a good ventilation and good airflow efficiency is an important factor. So, by conducting this study, maybe I can prevent and minimize the chance of virus from spreading inside a public building, especially when people go outside. For the objectives of this simulation airflow study, the first of all is to do a modeling on a simple human model with heat generation and carbon dioxide produced at a certain time, which is the amount of heat generation and carbon dioxide produced by human at a certain time, which is maybe the time duration during the prayer, for example in 3 or 2 minutes. Next is to simulate airflow inside the small MOSQUE with a available number of people, which is using air conditioning ventilation. And also for the distance between human inside the building, we will use a SOP during COVID-19 pandemics, which is 1 meter from each other. Next is to analyze the various parameters, in that including that related to the airflow study, including surrounding temperature, carbon dioxide, amount of oxygen, pressure, humidity, and velocity fluid inside the building by using MOSQUE software. Next, for the scope and limitation of the study, in this simulation airflow study, we will use MOSQUE to conduct a simulation inside a small MOSQUE. And for the human model that will be created, that will be inside the MOSQUE area, will have a distance 1 meter distance with each other, which is follow the SOP COVID-19 pandemics. The site study in the small size, the size of the site study also is 40 meter times 20 meter, which means 280 meters area. The parameter analysis are also is surrounding temperature, amount of carbon dioxide, oxygen, pressure, and velocity inside the small MOSQUE with specific number of people. So this is a parameter that related to the airflow study. So all the parameter will be finding by the end of this finding of the study. For the tubular model will be created by air rotation in the MOSQUE. For the temperature of the study will be 35 degrees Celsius. This is ambient during the day. So next, I will explain about my methodology method that have been used in this study. So basically, I have 10 phase of methodology. For the first one is document analysis, which is I make a research and initial study about the journal that have been found on the internet source. Then I use the result of the other researcher finding to be used as my guideline to to be applied in the my study also. Next, I identify the important parameter of the study from the previous journal that have been found. I use the parameter that they use as my guidance also for my study and select which is the parameter that related to my study. Next, I start the design and development 3D, the modeling of the MOSQUE and the human model by using the standard measurement that I have been found for the nearby MOSQUE that have been researched. For the human model also, you're using the standard measurement of the human body. Next, after I will finish developing the 3D modeling, I will assemble the human model inside the MOSQUE model. Next, after I assemble all the 3D modeling, I import the 3D model into the CFD software, which means I design the model by using the SolidWorks software, and I will import them to the CFD software, which is I use AnyFluent software. Then in the AnyFluent software, it will be a meshing method, meshing process, and set boundary condition, and set the tubular model. And after finishing all that phases, we can start the simulation run. After we run the simulation, we can find the result analysis and make a conclusion about what have been found by using this study. Next, we proceed with the step-by-step analysis process that have been done. So, first of all, we start with the 3D modeling of the small MOSQUE and human model. This model will be created by using a SolidWorks software. Then the dimension that I use to create the model of MOSQUE based on the finding nearby MOSQUE. And for the human, it's just a simple human with a standard measurement. Then after finish the modeling, we will proceed with the assembly the 3D modeling, which means I will assemble the human model inside the MOSQUE by follow the SOP during COVID-19 pandemic, which means 1 meter between each other of the human model. Next, after finishing the assembly phase from the human model inside the MOSQUE, the 3D model will be imported into the workbench of the AnyFluent. The model need to be saved in a IGS format because before inserting in the AnyFluent, because the AnyFluent can only read that file format. After successfully importing the 3D modeling, the model will insert into the mesh process. The meshing process is the process which the continuous geometric space of a model is broken down into thousands or more space to properly define the physical shape of the model. The mesh will influence the accuracy, the coverage, and speed of the simulation. After finishing the meshing process, we will continue with the define the parameter, use, and boundary condition. For my study, the air conditioning system will be the inlet, and the window and door is the outlet. Next, we will proceed to the next step is insert the input of parameter. Follow the research finding, for example, the velocity value and temperature value. Next, I will choose the type of fluid used in the simulation. For the simulation, I will use air as a fluid component. Next, after we select air as a fluid component, we'll proceed with the set tubular model of the study. In my study, I select a Sparlat-Armalas tubular model is used for this simulation study of the inside the MOSQUE building. Next, I will simulate the airflow inside the MOSQUE, which means I will run the program. I will run the model program in the AnyFluent software to know how the airflow inside the MOSQUE. Then, after I got how the airflow inside the MOSQUE, I will analyze the parameter. For example, it's analyze the temperature, carbon dioxide, oxygen, humidity, pressure, and velocity fluid inside the MOSQUE area by using graph analysis. Next, I will define amount of heat and carbon dioxide released by human inside the MOSQUE. And the last phase is I will record the results. Or I will record the parameter study and make calculation about the findings that have been found. Next, I will proceed for the expected result. At the end of the study, I expected the result that have been got, which means I will produce the 3D modeling for the small MOSQUE and human model. Next, I will demonstrate and simulate the airflow inside the small MOSQUE model that using air conditioning as the ventilation system. Next, I will determine all the parameter study that related to the airflow. which means that I've been said before, which is acidity, humidity, carbon dioxide, and all about the oxygen level. Next, I will obtain which is a carbon dioxide and heat generation release from the human body. Next, this is a preliminary result that I have got so far. This is a MOSQUE model that have been created in the SolidWorks. The area of this MOSQUE is 45 feet times 66 feet, which means 40 meter times 20 meter. For estimation, the green side is show a positioning of the human model that will be placed inside the building. Follow the SOP of COVID-19 pandemic, which means 1 meter from each other. Next this is basically a layout dimension in a meter of my MOSQUE models. Window and a door and all the dimension of for the thickness I will using 0.3 meters. Next, this is basically a testing of assembly human model and air conditioning system in a MOSQUE model that I have got so far. For this, I have added a roof at the top to show that because in the NS flood study, we need to make sure that all the parts are closed to make sure the analysis can be done correctly. Next, this is basically a machine process of the MOSQUE model after I have been inserted in the analysis plan. This is to define the real shape of the model. Next is the result of the velocity streamline that I have been got inside the MOSQUE. The result show the airflow of the streamline from the coming from the air ventilation system, which is I use a split type unit aircon. In this MOSQUE, I have created eight of the aircon split type. So the figure show the streamline of the airflow that produced by the air ventilation inside the MOSQUE. Next is I will show how the airflow simulation that have been got from the preliminary result of my small MOSQUE model. This I will show to you how the airflow movement inside the MOSQUE. For information, the velocity that have been used is 15 meter per second. The blue movement is the airflow of the inside the MOSQUE. I think that's all for me. Thank you to the panel that listening to my presentation. I hope my presentation will be clear to all of you. And thank you again to my supervisor, Dr. Muhammad, for guiding me to finishing this study. Thank you again. Assalamualaikum warahmatullahi wabarakatuh.